We want to know what is the product in simplest form and then state restrictions. Okay, so the product, remember, we're trying to see, are there places where something can reduce cancel? Okay, so the first one is x minus 2 over 5x. Okay, and then the next part we have is a 10x, not just a 10. And then over here on the bottom, if we factored out a 3, the GCF, we would have the following, x squared minus 4. Okay, so this difference of squares shows us we're going to make this x squared minus 4 break up into a difference of squares, which would then look like this. Let me go ahead and erase this part. And the difference of squares we know from factoring, we have an x plus 2, x minus 2. Whoops. And then now we want to see what pieces kind of cancel out. Remember, this is multiplication with one huge fraction and another. So it's like if we had one huge fraction all glued together with multiplication. That looked like this. So multiplied all these pieces together. So this would multiply, this would multiply, this would multiply, and so would this. Okay, so it's one huge fraction that now I know there's that x minus 2 and x minus 2. They cancel to a form of 1. This 10 and 5 will reduce to a 2 over 1. And now here's that discrepancy. This x will cancel out that x. And then I'm left with just these pieces up top and then these pieces on the bottom. So there's nothing else left to cancel. So if I wrote that down, I'd have 2 over 3x plus 2. Please do not think that you can, again, cancel these two because it has to be between multiplication pieces, just like I had over here. I can't cancel here because I have an addition piece, like we've worked on other problems, of a binomial factor, okay? So those twos cannot reduce to a form of 1. So since that's it, nothing else is left over to reduce, we would simplify it, and it would become 2 over 3x plus 6. This is our most reduced form. And again, please do not try to reduce this to and now a new 6 because there's addition here and it's a piece of a binomial. Remember, you cannot cancel pieces of a binomial. It's all or nothing, okay? So the restrictions, okay? The restrictions are any place where we're going to have this denominator piece of 0, okay? So if I went through the entire problem, there's 1. Okay, so we can list that one immediately. X is equal to 0. We know it cannot equal 0. So we're going to say it cannot equal 0 because it would make this piece undefined in the original problem. Whenever I had the factored pieces that came from this GCF, I know that this piece right here cannot be 0. Okay, and that showed right here that it would be a -2 or a positive 2 because, again, this piece factored out a difference of squares wise to the following, okay? So setting each piece equal to 0, we know that x cannot equal, for this first one, a -2, and then for the other one, a +2. So the restrictions stayed the same, but nonetheless, the most reduced form would have come to this right here.